All right, hello, lovely Year 12s. Just going to go through an exam question here with you, and it goes through each of the different scenarios of where you've got a unique solution, infinite solution, or no solution. So just to illustrate this, this is from, I think, 2017 semester 1 exam. So I'm just going to write that down there, 2017 semester 1 exam. Yeah, so it's in the calculator section, so you can literally just put this into your class pad to get the solutions. But I just want to show you how to do it non-calc, because it still is important to see those skills there. So first of all, what you're going to do is you're going to create a matrix with the values. So we've got here 8, 1, 1, 15, 2, 1, negative 1, 3, 1, negative 1, 2, and 3. So essentially what we said was, first up, was we want to make those values equal to 0. So basically I'm going to take 4 of row 2, and I'm going to take away row 1 and put it back into row 2. And then for this row here, I'm going to take 8 of R3, take away R1, and put it back into row 3. So let's go ahead and do that. So we're going to get 8 take 8 is, I'll do this first row first. 2 4s are 8, take 8 is 0. 4 take 1 is 3, minus 4 take 1 is minus 5, 12 take 15 is minus 3, 8 take 8 is 0, negative 8 take 1 is minus 9, 16 take 1 is 15, and 8 3s are 24, 24 take 15 is 9. Okay, so just by inspection here as well, we can see that R3 is minus 3 times bigger than R2. So I think this is going to lead us to the scenario where we're going to have infinite solutions. So let's go ahead and do it. Let's just do R3 plus 3 lots of R2 and put it back into row 3. And what are we going to get here? We're going to get 8, 1, 1, 15, 0, 3, minus 5, minus 3. And, well, minus 9 plus 9 is 0. 15 plus negative 15 is 0. Yep, and that's going to be 0 as well. So therefore we can say that, well, 0x plus 0y plus 0z is equal to 0. So therefore infinite solutions. And in each of these cases, interpret the system of equations geometrically. So we've said, okay, infinite solutions. Sorry, I just want to point out here that, so in that scenario, that's the next one we want to make 0. We've got infinite solutions, and then, yeah, so now we want to interpret it. So we've just got one of the, let's have a look here. So if we think back to, I'm just going to go back to the previous lesson here, and where we had the infinite solutions. And so pretty much none of them, none of the planes are scale, or none of the equations are scale factors of the other. So then it must be this third example here where 3 planes meeting in a common line. So we'll just write that down here. So it's going to say it is 3 planes meeting in a common line for that one there. Okay, let's come down to our second. Why is that doing that? So now let's come down to our second example here. I want to go do it again. So it's going to do, what have we got here? We've got 1, 1, -1, and 0. We've got 1, -1, 2, and 10. And we've got 3, -1, 1, and 16. Cool. Still looking at that there, none seem to be scale factors of the other. So let's go ahead and row reduce. And first of all, I want to make those two zeros. So I'm going to go and say, if I just do R2, let's do R1, I think so. Oh yeah, it doesn't matter. R2, take R1 and put it into R2. I'm going to take R3 and take 3 lots of R1 and put it back into R3. So what's that going to give us? Well, 1, 1, 1, -1, and 0. We're now going to get 0, -2, 3, and 10. R3 take 3, so that's going to be 0. Take 3 lots of that's going to be -4. Take 3 lots of this is going to be 4, and that's going to be still 16. Okay, and then in this final one, I want to make that one there a 0. So if I do row 3, take 2 lots of R2 and put it back into R3. Zero -2, 3, 10, 0. That's going to be a 0 there. So if I do 4 take 6 is -2. 16 take 20 is -4. So then I can say, well, okay, -2z is equal to -4. So z is equal to 2, minus 2y. Plus 3 lots of 2 is equal to 10. So minus 2y is equal to 4. So y is equal to -2. And then I can say that x plus y take z, which is 2, is equal to 0. So -2, so x is going to equal to 4. Okay, so there we have a, so to answer the question, which is determine a unique solution. Yep, so we determine it in each of the cases, interpret. So we can say that 3 planes intersect at a point. Cool. Alrighty. So I'm assuming infinite solutions, unique solution, and I'm just going to write here as well, unique solution. So this one's probably going to be a no solution. Let's have a look. So I'm going to say, make that a bit bigger. 1, 1. I'll bring the z to the other side, so it's -1. And then we've got 2, 1, -1, 1, 1, and 1, -1, 1, 3. Alrighty, I'll just rearrange that last one as well to bring the y to the other side. So here I can clearly see that the x, y, z component, so I can see that for those ones there, they're identical, but they're different values at the end there. So that's automatically telling me that there's going to be, it's going to end up with a 0x plus 0y plus 0z is equal to 1. I could go ahead and reduce it, but I can automatically, it's not asking us to go ahead and find, actually, what I'll do is I'll go ahead and do it anyway. So if I make those first two values try and equal to 0, if I say, let's do R2, take R1 and put it into R2, and R3, take R1 and put it into R3, that's going to be 0 minus 2, 2, negative 1, 0, minus 2, 2, and 1. Cool. And now I can make that minus 2 a 0 is if I do 3, take 2 and put it into 2. We're going to get 1, 1, 1, negative 1, 2, 0, minus 2, 2, negative 1, 0. That's going to be a 0, that's going to be a 0, and that's going to be a 2. So therefore I can say that 0x plus 0 z 2. So then I can say that let's say it doesn't work. So I can say, well, therefore no solution exists in this scenario here. And now I've got to think about, well, what could that possibly be? I'm going to come back to that previous lesson for where we have no solutions. So essentially what we can see here is we want to see if like any scale factors of another. So it can't be this that scenario there, because if we have a look, at if we have a look at the equations, two of them are scale factors of one another. So if I come over here, I can see, well, none of those equations are scale factors of one another. But we did have it in some of these other ones here. It can't be this scenario here because all three are scale factors of one another, which isn't the case. So that leaves us with basically it has to be one of these ones here. Well, actually, it can't even be that second one there because they're all essentially scale factors of one another as well within there. So it must be this particular scenario here where one's a scale factor and the other one's a random. So it must be two parallel planes with the other one crossing. So we'll write that down. No solutions exist, and what we have is two crossing through in that scenario there. Alrighty, so there we could basically determine those ones there. Determine a unique solution. So we could, in this first example here, we could technically find a solution or like a general solution. So I could go ahead and say I have 3y take 5z is equal to minus 3. And then I could say, well, let z equal to some factor, let's call it d. So we say if z is equal to d, then 3y take 5d is equal to minus 3. So in which case 3y is equal to 5d take 3. So then y is equal to 5d take 3 over 3. And then I can use that to then figure out an x value in terms of d as well. So basically, if z is a particular value, y is going to be a particular value in terms of that. And then you could go ahead and say, well, my other equation was 8x plus y plus z is equal to 15. And then, so I could say, well, 8x plus 5d take 3 over 3 plus d is equal to 15. And then I could say, well, x is equal to blah, blah, blah in terms of d. And so that would also be, that could be a general solution. And obviously there's infinite solutions because, well, d can represent any particular value, but so for whatever value d is, you could find the corresponding y coordinate and x coordinate as well. Okay, so that's just something else I just wanted to show you there, but I don't think it's asking it for you in this scenario here. Cool. All right, enjoy, guys.